5, 4, 3, 2, 1, 0.
Good evening, young experts. I'm Rukshan Vijay, the Divisional Manager of Biomedical and Earth Science Division, SEDS OUSL. Let me welcome you all to the opening ceremony of SEDS NuFora 2021 of SEDS OUSL. Let me first welcome our panel of judges, Dr. Kalpa Samarakon, PhD, NuFora Senior Lecturer at Institute of Combinatorial Advanced Research and Education, KDU, Care. Generous John Katalapa, and also Dr. Anoma Chandrasekhara, PhD, Professor in Food Science and Nutrition, Department of Applied Nutrition, One University of Sri Lanka. And I welcome Dr. Achala Palligera, Senior Lecturer at University of Kerala, Advisor of Sri Lanka Projects, to this event. And I want to welcome our guest speaker, Ms. Gagini Athukogara, undergraduate of Faculty of Sciences, Sabaragamu University of Sri Lanka. I would like to welcome you all to the opening ceremony of NuFora 2021 of SEDS OUSL. Let me introduce SEDS first. It is Student for the Exploration and Development of Space Sri Lanka. It is a part of an international organization aimed at promoting space exploration and development through educational and organizing engineering projects. In the path to the success, Biomedical and Earth Science Division of SEDS OUSL has organized an event called NuFora with the collaboration of sedssl. Okay, the NuFora 2021 is a competition which will open up to all undergraduates and school students from states or private universities who will compete by researching and producing nutritional supplements for astronauts by using seaweed and algae. This will be happening as a practical event and also done according to the global community's health and safety conditions because of this COVID-19 pandemic. Event will be held according to the terms and conditions which are provided by the organizing committee with the supervision of panel of judges. First, let me welcome Dr. Anoma Chandrasekhara to address the audience.
Thank you very much. Good evening, everybody.
Good evening, Doctor.
First of all, I would like to thank the organizing committee for inviting me as a judge to this very exciting event. Really, I haven't heard about this organization first, but after I came to know about the organization, I felt so excited And even with this pandemic situation, I feel so proud of all the organizers for gathering as well as for organizing this sort of exciting event. Our school children as well as our students are very motivated. They have a wide imaginations, but we need to give them opportunities. I think the organization has given that opportunity to all students. I hope we can see very exciting findings, very exciting products, which they are going to produce as well as proposing to give this, to contribute these important events. And I hope to give you my full support for that. I wish you all the best for all your future endeavors in these activities. Thank you.
Thank you, Dr. Anoma Chandrasekhara. Now I invite our guest speaker, Ms. Gagani Athukorala, undergraduate of Faculty of Applied Sciences, Sabaragama University of Sri Lanka, to start the lecture.
Right, thank you very much, Rukshani. I'm really happy to see such a beautiful audience with me in this evening, and especially two professionals are here with us, Dr. Anoma Chandrasekhara and Dr. Kalpa Samrakun. I'm really happy to see both of you professionals here as well. So, Akila, can I have my presentation, please? Space food. So first of all, I should express my sincere gratitude to the SEDS chapter of Open University of Sri Lanka for inviting me to have a kind of a warm-up discussion with all of you as a kind of actually the small discussion in regards with NuFora21. So my lecture or my presentation is going like this. In case I'm going to talk about few objectives regarding this food and space food. First, I'm going to talk about what is food and what is space food. And secondly, the concept of space food and nutrition. And thirdly, importance of learning about space food. And fourth, the concept of algae. And lastly, I'm going to talk about briefly about the challenge of NuFora21 that is organized in collaboration with SEDS chapter of Open University of Sri Lanka. So in the first objective, I have told you like food and space food will be delivering in this segment. So I'm going to talk about differences between the food we are having on Earth. All right, thank you. Can you go for the second slide, please? Objectives. Sure, thank you, perfect. So in this scenario, first one, I'm going to talk about differences between food we are having on Earth and the food the astronauts are having outer space. You know that there's a kind of a difference, maybe a big difference as well as maybe small difference. Let's see. And secondly, the concept of space food and nutrition. In this segment, I'm going to talk about what are the types, categories, the way food is packed and prepared. You know that there are slight differences how this food is going to get delivered to astronauts. So let's talk about that segment as well. Thirdly, importance of learning about space food. That means why you should learn about this space food. What are the future doors that will open to you if you are going to learn about this space food concept? Let's see. And number 4, this is talking about algae. This is the major concerns about NuFora21, that how you people are going to make food that is as a kind of easy method to easy to have product using algae, using the ingredient of algae, how you are going to product these, how you're going to process this product of maybe a biscuit, jam, or whatever the thing is. And lastly, I have told you that I'm going to talk about what kind of a what kind of a challenge is this NuFora21 is. All right, let's go for the second slide. Perfect. So you all can see a pizza on my screen, right? All right, so I want you to imagine two scenarios. Number one, imagine you are ordering a food like a pizza party while you are living on Earth. And secondly, I want you to imagine you are ordering a food, maybe you're throwing a pizza party when you are living in outer space. What would be the possible most? What will be the possible method? So no worries, there's no comment that you know that having a pizza when you are having a pizza and experiencing the pizza taste while you are living on Earth is the most possible act when comparing the astronaut's lifestyle. So you can see, so when we are weighing these two segments, I want to tell another thing. That means, let's see, we cannot exactly tell that astronauts will not be able to taste this pizza. They can taste, but preparation is different when comparing the segment we are having on Earth, right? So in that case, they can have flavors, they can add flavors, pizza flavor, whatever the flavors they like, and they can eat their own, but they have to make it up for themselves. But for you guys, you can call the delivery guy and you can ask, can you send me a pizza? All right. So what I want to tell here is, now you can see there's no big difference as well as there's no big similarity, right? Second one, just let's see, eating chicken and experience the flavor of chicken. Some of the vegan people are doing this. They don't like to eat chicken, but they like the taste, that means the flavor of the chicken, right? So in that case, the astronauts are doing the same. So in that case, that means they won't be able to have pizza as it is, but these astronauts, they are eating pizza with their own flavors, right? So now, so what I want to clarify here, what I wanted to clarify was, now you can see, we cannot see a very big difference as well as there's no very big similarity as well. Third, let's go for the next chapter. Next slide. Perfect, thank you. So now let's see what is exactly meant by food and what is exactly meant by space food. So you know that human beings need energy, right? So in order to take energy to their body, they should, food should be there, right? So if you want to be a fit person, if you want to live a healthy life, then where these energy particles are coming, then the food is available for you. So food is one of the sole needs of human beings, energy producing factor. It's crystal clear that everyone knows that the food is the major energy factor which gives you much longevity, much healthiness to your body, right? And the second one, see, space food. Space food going to be a little different from the food we are having on Earth, right? So the space food has specific requirements of providing balanced nutrition for individuals working in space while being easy and safe to store. Yeah, easiness should be there. You know that maybe let's imagine like when you are having a packet of chips on your hand and watching a movie, the favorite movie you like, then you can cut it maybe using your mouth or maybe using a scissor. You can cut it out and you can have your chips on your own. It should be that simple when you're dealing with astronauts' food system, right? So I want all of you to cast your mind back to the ancestors' time period, right? If you can remember how our ancestors stored and how they managed a whole food system, right? So our ancestors discovered that food will be remaining for a longer period if it were in the dried condition, and as well as if it is stored in a cool, dry place until it was time to be consumed, right? So in that case, the major fact, the basic lie in the foundation was laid to today's astronauts' food system, that is dehydrating. So you know that dehydration means taking all the water particles out of the food that technology has increased. So everything, it was getting developed day by day, right? So then with the experiments, new techniques were developed for cooking, processing, preserving, as well as storing. So all these segments were developed with advanced technology. So then with these conditions, astronauts and food technologists and all the scientists who are having a relationship with the space food and nutrition for our astronauts, exactly. So they use the same method, but with much advanced technology. So that they have to care about the procedure well, how much of calories, vitamins, minerals, what are the types they should add, and as well as zero gravity environment that should be working. So let's talk about more deeply when we are going with the future slides. Next one, please. Perfect, thank you. So in this segment, now we are moving to the segment number 2, the concept of space, food, and nutrition. So now you have a slight idea, what is the difference between normal food system that we are dealing while we are living on Earth and the space food system that astronauts are dealing with when they are in outer space. So let's go for only for the concept of space food and nutrition, because this is our major concern. Let's go for the next slide. Okay, thank you. So this is the question: what do they eat in space? Now we already know what are the types, what are the things they are eating while they are living in space, but let me add some more things. So as I have told you before, it's not totally different, but somewhat different. So from the way food is prepared, from the way this food is packed, delivery, all the things are not similar. There is no similarity between the way the food we are having on Earth and astronauts. So, but we are having 3 meals, right? Like breakfast, lunch, and dinner. So as well as they are having the same. They also have a breakfast, lunch, and dinner. But nutrients must be contained in a higher position, right? So nutrients ensure the food astronauts eat, always they should provide with a balanced supply of like vitamins, minerals, as well as some of the proteins. So in that case, food scientists have to concern more about this nutrients level of these astronauts. Let's say just for an instance, just for an example, let's take a small woman, small-sized woman, right? And as well as a well-built muscular person. So both these personalities are going to get into the spacecraft, and what if what will going to be happen if we are producing, if we are giving the same meal for both of them? Will it work? No, right? So let's take the small woman. So small woman, nearly the small woman requires 1900 calories a day. And let's compare this well-built muscular person. Maybe that person needs like 3200 calories. About astronauts' food, you have to concern about each person separately, right? So when these astronauts are invited to test and tell about the feedback, what would you feel about these meal timetable? They can choose either, there are lots of food, right? So they can choose like fruits, nuts, peanut butter, maybe seafood, as well as candy, brownies. Liquids also, they are going to have liquids even in the spacecraft as well, like orange juice, coffee, tea, but the preparation is different more than our Earth. Let's go for the next slide. Okay. So now you can see there are two astronauts in this picture. There are two astronauts. They are enjoying their meal, but see the what is happening to the food particles. So here you can see in space environments indirectly microgravity. You should know about this when you are preparing food for astronauts, right? So let's see, like when we are taking, I just want you to imagine you are now in a spacecraft. You are having a piece of food in spacecraft. You are just going to tossing it up to the sky. But will you think this will be able to come down? No, because gravity doesn't work there. So these food particles will drift around. So this is why when even they are eating, when we are having their meal, they have to concern about even the single food particle. Just imagine if one of the food particles accidentally getting released by astronauts and going and stuck in one of the spacecraft's tools or whatever the thing, the spacecraft will be damaged with these food particles. So when they are producing these food items, these are the factors that even for the food nutritionists have to be concerned on. So as well as I just want you to cast your mind back to the first space mission program. So there the food wasn't a factor. Food actually doesn't matter in that space mission, in the first space mission, because it lasted for like few minutes, right? So but you know that now with the advanced technology and with the advanced space systems and space concepts, they need to be conducted like longer journeys in order to explore the space perfectly, right? So I think you had an idea about these food particles, the way they are moving here and around. So can I have the next slide? Perfect. So here, can you see the first one? The first picture, you can see this is the applesauce. This is the first meal that is tasted by astronauts in their first space mission program. So just see how this applesauce is packed. Do you think that when you are going to any of the supermarket like here, Zukagis or anywhere, do you think if you are asking someone, can I have a applesauce? Do you think that you will be able to have a toothpaste like stuff? No, right? So then you can have to go for a packet. They are offering you a packet or container or whatever, but rather not a toothpaste like thing, right? So what I want to tell you here, see, they are tasting applesauce, but see the preparation, the way it is packed, it's different, right? So here, it's kind of, it's that simple. The astronauts squeeze these, what is inside into the mouth, and they can enjoy their flavor. So this is the way this first space mission conducted their space and food concept. And it's I think you can see the third picture. See the way these food ingredients are packed. The package, and you can see in the top layer of the packet, there's a nozzle, right? Why this nozzle is prepared? Then you can open it up and I will show you. There's a machine to tuck it, and then the water is injected, and there you can have a cereal-like stuff. Astronauts can eat something like that, right? So next slide. So in the next slide, I can show it to you. Thanks. So here you can see, this is the method that those people are using, how this food is used. Now you can see in this picture, this product is entered into the machine and food is injected through the nozzle, and then just step by step, water is coming to the packet, and then you can have a cereal-like stuff. I hope if you are a bigger fan of cereal, you can remember how you are making cereal, like adding hot water or hot milk to the bowl and you are making your cereal. It's that simple, even for the astronauts as well. So in the next photo that you can see, if you are going through the NASA's website, you can have this food. These food can be tasted even for you, because they are just having online delivery systems. So even if you are much interested, go for the NASA site and you can have these kind of items with you all. Okay, next slide. All right. So here, even for the astronauts, they are having a menu card. When you are going into a restaurant, the server will give you a menu card to choose whatever the meal you like. But in that case, you cannot find any abbreviated forms, right? But for astronauts, using abbreviated forms, it's one of the easiest thing to remember what kind of a food item is this, right? So for these are several things. These are the main factors that space astronauts are much familiar with. Abbreviations are working when they are dealing with their meal system. Like artificial sweeteners is standard with A, S, and beverage B, fresh food with double F, intermediate moisture with IM, radiated I, natural form NF, rehydratable R, and thermostabilized with T. So in the menu cards, most of the time in the menus of our astronauts, they won't be able to find these longer names, but AS, B, double F, IM, likewise, mostly they will be getting familiar with these abbreviations. So these are the main abbreviated forms they are using when they are dealing with the space food and nutrition system. Okay, next slide. Okay. So here, these are some of the exemplary packets or the samples of the names that what kind of food types that these astronauts are using. So the names I have followed up here, the names I have added here, it is going in accordance with ISS. You are familiar with that, I know, International Space Station. So here you can see specially packed fruits and vegetables, salad, meats, fish, beef jerky, spaghetti, soups, curds, savories, and sweets, as well as liquid drinks. So these are, you can see the name specially packed. So you can see not just we cannot take a bottle of apple juice or lemonade and you cannot entering into the spacecraft. It should be specifically or specially packed ones. Okay, next slide. Okay. Yeah, now let's see how does it work. I mean, like, is there a procedure? What kind of procedure these people are following, these food nutritionists are following, if they are really working on this matter? So now let's see what are the procedure and what are the types, what are the steps they are following in order to give the best meal for the astronauts. Let's go for the next slide. Cool. So here you can see a picture. Food lab at the Johnson Space Center. That is a responsible party for the whole procedure of astronauts' food. Under its consultation, all the things are inspected and all the things are delivered to the astronauts. And secondly, you can see scale products out in a 1 to 9 scale. Yes, so this is the thing. There's a huge table for astronauts and astronauts are invited. They can sit together and food particles, that means food products are given to all of them. And there's a scale as well. So if that person is much interested with that food product, he can touch number 9 or 8, whatever, from 1 to 9. He can choose whatever the scale he needs. Just like that, let's take cookies. These brownies are one of the favorite food items of astronauts. They really love it. So in that case, probably almost all the astronauts will give 9. And for like spaghetti stuff or whatever another food product, they will give like 7, 8. It depends with the person's meal procedure. And next one, needs to be engineered for a zero gravity environment. I have told you before, that's microgravity. So all the food should be engineered to this level. So whether not just like on when you are tossing up something, it will coming down, but you cannot do the same thing with when you are dealing with the microgravity environment. So food nutritionists, as well as if you guys are having the hope of to go to the space as well, I'm wishing you. And you have to concern about these segments as well. And lastly, easy to prepare a nutritious meal, of course. Whenever if I mean there are so many food products are available within their context. When one is taken one food product, it should contain the nutrients level to the maximum level. Then only that food product will be useful for the astronaut. Okay, next. Let's go for the next one. Okay, thanks. Microgravity. I know all of you know about microgravity, but I just want to stress out here. As I have shown you in the screen, the zero gravity environment, gravity's effects are greatly reduced. Microgravity occurs when the spacecraft orbits Earth in the state of free fall, floating of food items. So these are the segments that we can experience if you are having experiences with the microgravity. So here, each and every food items, each and every food products that is going to get prepared for the astronauts, they should concern about this factor, microgravity environment. So just like I have told you, when we are talking about a packet of chips, when we are taking chips out of the packet, and it should contain that much easy to deal with the astronauts food system, as well as when it is eaten by the astronauts, it should not be a mess completely, right? So those are some of the several factors that food scientists have to concern about. Let's go for the next part. Yeah, next slide. Several facts to concern. Let's see. Okay, thank you. So here, so these are the, yeah, next slide, please. Okay, sure. Thanks. So here, you can see these are some of the other several factors that you have to care if you are making a food product to the astronauts. Number one, healthy menus with unique requirements. Yes, it should be a healthy menu. Each and every person should have a healthy menu with unique requirements with high level of nutrients. Easy to handle, of course. Just as easy as I have told you, opening a packet of chips and having it on your mouth, for your mouth, right? So it should be that simple. And next one, all the menus contain between 1900 and 200 calories per day, depending on the astronauts. I have told you before this. So when we are considering about each astronaut, they have to consider about weight, gender, specific needs, right? So that's why I have told you in the very first segments, there's a table for astronauts, and they can scale it out whether that person likes it or not. So next one, require no refrigeration. So require no refrigeration means, you know that just like on Earth, we are not going to have a refrigerator in the spacecraft, right? So there's no refrigeration means there's no refrigerator. So these food should be considered without not having a refrigeration effect, right? And the next one, to remain healthy during the space light. Yeah, so that means when you are these astronauts are going, that means dealing with the spacecraft, inside the spacecraft, so they have to almost all the time they are inside the spacecraft, right? So in that case, they have to food nutrients, they have to care about what kind of period of time, what will be the calories, how they are going to produce more energy. Likewise, they have to concern about these factors. So now let's go for the next part. Okay, thanks. So this is one of the major things. The Space Food Systems Laboratory has food processing laboratory, food packaging laboratory, and an analytical laboratory. So these three are very, very important when you are making food for astronauts. Let's go for the food production. That means food processing laboratory. In here, this food produces thermally stabilized pouch foods and freeze-dried packaged foods. So here you can see I have told you this dehydration and freezing food. So in that case, this food processing laboratory, they are concerning and they have to concern about these segments as they have learned in their space sciences. And for the food packaging, you know that the way these food are like, let's see, we can have a variety of unique packaging equipment with including heat sealing. There should be heat sealing and vacuum packaging, labeling, and should be prepared with a clean room environment as well. The clarity or the cleanliness should contain in each and every food products, right? And when talking about an analytical laboratory, this is the where in this case, this Johnson Space Center laboratories including microbiological and moisture, color, texture, as well as sensory. So in order to care about these factors, this analytical laboratory is majorly concerning about these factors as well. So when we are dealing, up to now you know, when we are making a food, making kind of a food product for astronauts, you have to double concern with these factors I have told you. So next, please. Yeah, here there are two pictures. So this is the Space Food Systems Laboratory. So here, this laboratory is equipped with a test kitchen. There's a test kitchen, as well as the packaging facilities are there, as well as the the way dehydration and freeze drying facility. These facilities are contained in this laboratory. And as well as you can see, this is Space Food Systems Laboratory. You can see NASA JSC. This is one of the, I know that you are much familiar with this symbol. So in this case, this nutritional biochemistry lab is a part of a kind of a large group. That means JSC is having the connection between these two segments. And probably all these laboratories are working together to give a good, perfect meal to the astronauts. Next slide. All right, so now we are moving on to the projects with space, food, and nutrition. So far now, you know, I have just mentioned here only 7. So far now, you know how many projects have been implemented to give the best advanced technological food, space food, and nutrition for astronauts. So number 1 is Mercury, 2nd Gemini, Apollo, Skylab, Apollo Soyuz test, Space Shuttle, International Space Station, which is standard for ISS, right? So number 1, Mercury. You know that this is the earliest space program. This is the most ancient, this is the ancient space program that has implemented by the astronauts. So in this case, in this Mercury project, the food wasn't, actually I have told you before, this food, the fact of food wasn't really an issue. They somehow managed it because it has lasted for a few minutes. And for the Gemini, in the project of Gemini, they have used improved packaging more than the Mercury project. And as well as there's a kind of a fact that each crew member was supplied with 0.58 kilograms of food per day. I know you are much aware with these facts. And third, Apollo. Apollo is the third mission. And in the Apollo mission, it was everyone can see that there was a significant improvement when compared to other Mercury and Gemini projects. So it was what even they had the toothpaste like stuff, like squeezing from a tube and directly into the mouth. They can taste them, as well as they that as well as there's a thing that astronauts are always having in their pocket, that a pair of scissors. So they should have a kind of a pair of scissors in order to cut it out and to have them. Most of the time these scissors can be attached to the spacecraft as well, but recently I have seen in an article that they have stated that the most important one of the most funniest thing that astronauts are having in their pocket was a scissor, right? So then it's easy to have their meal by their own. And the Skylab number 4, so in the Skylab, you can have a kind of these astronauts can have an experience just like they are having in the home. Like Skylab is giving you the that personal space too. Like in this Skylab laboratory, they are having kind of a freezer as refrigerator, warming trays are there, and a table to eat. So these are facts that we can see compared to other projects. Skylab is having this kind of tools and utensils in order to support for the astronauts' meal and nutrients. And next one, the Apollo Soyuz test. So Apollo Soyuz test, it was kind of they also had a small heating unit on board, and just as I have told you in the Skylab, they even had a kind of individual meals. They can even select what they like if they like meal consists with meat, or maybe another person will taste meat paste, bread, cheese, soup, whatever the personal taste can be tasted with this situation, with this mission. And number 6, it's space shuttle. So in this space shuttle, I have seen that in an article that they have mentioned, like within 5 minutes they can set a meal for 4 astronauts. So it's that much real quick, right? So you can see. So what I wanted to show you here is, see, every project was improved with advanced technology. When just think about the future, just people like you, that's the people like you, that is why world needs people like you with much knowledge. So I think that the astronauts food system will be much more advanced and much more easier with the future upcomings. And lastly, this is International Space Station, ISS. So it's a kind of a modular space station where they can experience like low Earth orbit, that is in the low Earth orbit. And here I can remember that this meal prepared for like 5 steps, using 5 steps. Like they are going to reheat the meal in the oven, or maybe rehydrating. And secondly, they are preparing the beverages, maybe even with the rehydrating or with hot or cold water. They are having those facilities. And then you can cut the meal with the scissor, and you can eat it by using all these ingredients and all these procedures. So as I told you, these 7, I have here followed up only 7, but there are many more advanced technologies now, even it's ongoing. So space food projects that are implemented in regardance with space food and nutrition was Mercury, Gemini, Apollo Skylab, Apollo Soyuz test, Space Shuttle, and International Space Station. All right, so let's go for the next slide. Yeah, so here, categories of space food. So you know that mainly there are 8 food types that we can see when we are dealing with astronauts' food systems. Like number 1, rehydratable food, thermostabilized food, intermediate moisture food, and number 4, natural form food, number 5, irradiated food, number 6, frozen food, number 7, fresh food, and number 8, refrigerated food. So these are some of the food, these are the main 8 food categories that the astronauts are dealing with when they are having their own meal, right? So in dehydratable food, you know that in these food products, the water is removed. You cannot see any water substance inside the food product because the water is removed, and it is so much easier to store even. So when in case if you need it to be rehydratable, you can, as I have told you before, you can inject water inside to the packet and you can have it on your own, right? So next one is thermostabilized food. So these thermostabilized food are heat processed ones. So even these food items can be stored at a room temperature, like not like the rehydratable food. So these thermostabilized food, they are having another segment of the way these food items are stored. So intermediate moisture foods, these food products are preserved by taking some water out of the product while leaving enough to maintain the soft texture. I have taken these ideas from an article. If you can refer, I think maybe some of you are much familiar with the facts I'm telling, but I'm just reviving you all the things. So here's these intermediate moisture food products. They are having a kind of a taking only some of the water, and the texture of the food products are being maintained. And the natural form food, that is the best food type that astronauts are like the most. And in that case, that means nothing is done to the food. Like they can have it just in the natural form, ready to eat, and package is flexible. So likewise, in this case, you can for an example, we can tell like nuts and vegetables, fruits. So these can be taken in the type of our natural form food. And the next one, radiated food. So radiated food, these products are like cooked and packaged in a flexible foil, right? Maybe if you can remember the pictures I have shown you before, maybe you are much familiar with these the foil that I have shown you, right? And for the frozen food, these foods are quick frozen to prevent a buildup of large ice crystals, right? So in this case, the original texture of the food, it is helping and it is tasting much fresh more than the other substances that they are eating in the space. So fresh food, we can just like apples and like apples, vegetables, the what astronauts like the most, they can eat in the way it is. Like probably the fruits are going under this category. And the refrigerated food, so these food require cold or cool temperature, just in order to prevent rotten scenario, just in order to prevent rotten scenario or not to be getting spoiled. They have to use these food particles have to be used in a cold or cool temperature. So maybe you are much more aware with these food categories more than me. So let's go for the next part. Okay, yeah. So this is the thing I'm going to talk about now. Importance of learning about space food. I have asked you before why you should learn about this space food concept. Why? What are the future doors? What are the benefits, opportunities you are having when you are learning about this space food concept? Yes. I want you to tell, like, you know what has happened to dinosaurs, right? How they have extincted, right? So if we don't do much experiments with the space while supporting our astronauts, we won't be able to see what are the upcoming threats for the Earth. What are the upcoming threats we are having? Is our Earth in danger? So in order to clarify all the things, in order not to get extincted, we have to concern about more space missions. So there you have to produce more advanced technological food items for the astronauts. So that's why you should learn about and you should be more concerned about the fact of space food, right? So not unlike the prior space missions we had, unlike the prior projects we had, the future upcoming projects will be having much longer period to stay in the space, or and astronauts have to be stay much longer in the spacecraft. So then we have to concern about more when we are producing food items for them in the future. So this is why you should learn about this space and space food as well. Okay, let's go for the next one. Okay, thanks. So here you can see more experiments, a hope for the mankind. So if you are doing something, if you are inventing something new in order to as a help for the astronauts, then you are helping for the whole mankind, not just for the Sri Lanka, not just for only one country. You are helping for the whole mankind. So in this case, the scientists are believing that the future astronauts will be taking the responsibility of gardeners as well. So you can see a picture. They are predicting that this gardening concept can be implemented in the space craft scenario. So in that case, I have seen in an article that they have mentioned like astronauts will be able to grow peanuts, spinach, cabbage, lettuce, rice, as well as other vegetables they have stated there. So these are the things that NASA is concerning about making a spacecraft or making the space kind of a gardening concept. So this is the thing. This is the way the food and nutrition, the future of space food and nutrition. Now you can see, now you can imagine what kind of a future will be lying with the space food and nutrition, right? So next, let's go for the next slide. Yeah, here I can mention like how to produce improved food products, more tastier food with the interest of each astronauts, improve it at least from a single aspect. Yeah. So when you, this is what I have told you, that's why this is why you should learn about space food. When you are eating the when you are eating the same food again and again, do you think are you feeling like nervous, or are you going to like that food? No, right? So because it won't be able to taste much nicer. So new food products, new food items should be implemented. So in that case, you have to, then if you are much concerned, if you are passionate about space food and nutrition, if you are learning about that concept, then you can have the idea like how to produce improved food products, more tastier, and as well as to respect each astronaut's meal favorations. So, and I'm just giving you like a kind of a invitation, like improve it at least from a single aspect. Yeah, if any one of you guys can improve this food particle at least from one single aspect, that means you have owned it and you did some kind of a great thing to the mankind. All right, so next slide, please. All right, so this is one of the major concerns that is NuFora21 is lying down with. So the concept of algae. The concept of algae, you know that when we are talking about this algae concept, by 2050, the world's population is going to get hit almost like 10 billion. This is not a fact of mine. This is the way scientists are telling it. So they are telling like by 2050, the world's population will be going to get hit by 10 billion. So in that case, they have to produce 70%. I mean, more than 70. The food production should be increased. Will be getting increased like 70%. So in that case, they are stating that probably the traditional food production will be getting away from the food system. That means traditional food the way these food are being prepared while respecting or while laying down with the traditional food concepts. So these scientists are telling that this will be going away with the upcoming future things. So in this case, this algae, the ingredient of algae, this product of algae is coming to the stage. So this tiny green protein-rich solution is algae is the best solution that anyone can have in the future. So if you are running a business, if you are having the hope of running a business, you must be concerned about algae, because it's going to be the most best product in future by like 2050. So here, let's go for the next slide, right? Okay. Now here, if I want, or if you want to have a kind of a slide definition for this algae, I have screened here a wide range of eukaryotic marine organisms which engage in the process of photosynthesis. Right. So you know that, I know that you have seen the product of algae, right? Maybe you have touched it or whatever. So in that case, this algae needs kind of a variety environment. That means like not variety, watery environment. That means like ocean, river, lakes, ponds. So you have seen that all the algae products, they need kind of a watery environment to grow, right? So in this case, as if you have seen it very clearly, probably, I mean, almost all the algae, they are containing the color of green. So, but there are different colors as well, but probably normally they are having this color of green. So you know that our plants, traditional plants, all our plants on earth, they are having the systematically thing of photosynthesizing, right? So algae, even for the algae, they can do the same. So algae can photosynthesize like other plants, and even but even they possess a specialized structures, even like cell organelles, like centrioles and flagella. Even these things can be found that only in animals, right? So you can see why this algae is going to be the future, the food of the future. So when we are talking about the characteristic of algae, we can maybe you are much aware that algae can be either unicellular or multicellular organisms, and as well as algae don't have a kind of a well-defined body. We cannot have a specific group, specific structure, and as well as these algae don't have that roots and stem, leaves, that the structure we are expecting from a plant. So and let's go for the next one. Okay, so I want you to think about this product of algae. What are the products? Or are there any products that has implemented recently or in supermarket, if you can find it, using the ingredient of algae, whether we can find it or not? So you can see algae is one of the most productive ingredients, most sustainable ingredients, 7 times more protein and other nutrients properties than soybean. Yes, so these are all these things have been tested by the food scientists relating to the space food and nutrition. They have worked on this for several times, and now they are, see in the picture you can see this item is this food product is prepared while using the ingredient of algae. So this is why I have told you algae will be the food of future. But if you are much interested, you may be having a question like why these algae products are not in the supermarket, why we cannot find it in the supermarket. Because the processing of algae, the whole process of algae is so expensive. So in that case, only that's why we are having lack of products in our supermarkets as well as other shops, because this whole process is much expensive rather than we are expecting. So let's go for the next slide. So yeah, this is the just these are so simple that these are the uses of algae, like biofuel, like fertilizer and vitamins, pigments, pollution control. I hope you are much aware with the session that one of the professionals has done for all of you. So you are much aware of these things. What are the uses of algae? Likewise. So let's go for the next slide. All right, so these are some of the types that I have listed here with that is going with the product that is going with the ingredient of algae. Like green algae is one of the famous one, and then next one we can have other like foie algae, red algae, yellow green algae. So these are some of the algae types you can find when you are when you are going deeper in the subject of algae. So let's go for the next. Okay, space food and algae. So this is what you were in need of, right? Here now, what do you think about what is the combination? What's the relationship between the product of algae and the space? Yeah. So this product is nicely growing, you know that, and it is producing a lot of oxygen. But these days, scientists are just concerning that they want to verify whether it is really working as the same on Earth. Even we are going to do these experiments even in the outer space. So they are stating like that it will be exposed to higher doses of radiation. You know that when the astronauts are going to the space, what kind of environment they are experiencing. So in that case, they have to they are getting exposed to higher doses of radiation coming from the sun, and as well as weightlessness is there, right? So the scientists are concerning whether these particles should be whether they have to concern about a more advanced science when we are dealing with algae, the product, that means ingredient of algae, when they are dealing with the astronauts food. So let's go for the next one. Yeah, so here, so you know that the scientists are they are stating that this algae is, I have told you, it is one of the rich nutrients one, and they are containing vitamins, proteins, supplements. Likewise, they even if you have Google it, or if you have seen it, even the some of the pills, some of the tablets are made with this ingredient of algae. And next, nutritionists suggest the blue-green algae are storehouses of omega-3 fatty acids. You know that omega-3 is one of the most needed for the human being's body. So in that case, these nutritionists are suggesting that blue-green algae is having the relationship to this factor of omega-3 fatty acid, right? So this one, the third factor is preliminary testing to produce oxygen and to remove the CO2 from the atmosphere. Yeah. So what they want to test here is producing oxygen and remove the CO2 from the atmosphere. So algae is algae, and ingredient of algae, they have the potential of this producing oxygen and removing CO2. So these days, these like scientists are working on that, whether what are the other things we can work with, what are the other things, other missions we can implement with this product of algae. Let's go for the next one. Okay, so I hope you are much aware with algae bioreactor. It is, as you can see on my picture, this is the way it is. It can be shown. So I have printed here like CO2 into O2 to generate food. Yeah, they are concerning about that aspect. And the photobioreactor contains an algae species. So Corolla vulgaris is the item that ingredient that is contained, that is aligned with algae bioreactor. So you can search more things about this algae bioreactor. YouTube is one of the resourceful way to search about this thing. All right, next. Okay, so now we are coming to the last part of my presentation. So NuFora21, it's really fascinating competition that has been organized by the Open University of Sri Lanka, SEDS chapter of Open University of Sri Lanka. So it's really fascinating, and I know that, and you should know that these kind of, when you are getting getting activated or getting participated in this competition, it will open more doors to your future. You will have more opportunities, you will have more chances to open or to spread out your knowledge with others or to the world. So I'm telling you, if you are much interested, if you are a space enthusiast, then you can go, or then you can apply for competitions like this. Then you can open your own door, right? So in this NuFora21, you people have given a kind of a challenge. You had to produce an edible product using algae for astronauts. So maybe now all of you know how this should be done, how the preparation, how the delivery, all the things should be which can be aligned with astronauts food system, right? So next one. All right, so thank you. I'm going to so this is the end of my presentation. So in this case I have to tell you guys, I'm really happy again. I'm really happy to see, and I'm really happy to let you know that. And thanks again, OUSL, for inviting me to this competition. And I'm again, giving my thanks to our two professionals we are having tonight. I hope you have enjoyed and you have gained some of the knowledge through mine. So if any technical errors have made from my part, I'm really sorry for that. So thanks everyone.
Thank you, Miss Gaganyathakara. And I should say thank you all for being with us on such short notice. And this opportunity is for you, our audience. You can clear your doubts by asking any question from her. Miss Gaganyathakara, is that okay with you?
Rikshani, I just want to make a comment. I'm really sorry. I just thought to have a Q&A session with all of you, but I'm really sorry. I just got to go for another session. So if any case, if you guys got any questions, you can use my official email address. I will put that into the chat box. So in case if you got any question, or if you want to tell me, drop me any feedbacks regarding mine, you can use my email. Surely I'm going to be reply by tomorrow. So thanks again and have a good night, all of you. I'll be putting my official email address to the chat box.
All right. Thank you, Ms. Gaganyathakara. And now I invite Ms. Tashmila Arlia, the chairperson of SEDS Sri Lanka, to address the audience.
Thank you, Lang. Can you hear me? Yeah. Thank you, Langi. Thank you very much for the organizing committee as well for giving me this opportunity. I think all of already had a really informative session with Ms. Gaganyathakara. Thank you very much for the session, Miss. And as you know already, today we are joining with the opening ceremony NuFora competition 2021. This competition is for the first time we are organizing such an event on the theme of nutrition to the astronauts. First of all, I should thankful to SEDS OUSL, SEDS Open University Chapter Board of Members and to the organizing committee for organizing this event successfully. Actually, according to the initiative of SEDS Sri Lanka Biomedical and Earth Science Division. Students for the Exploration and Development of Space is a non-profit organization that empowers young people to participate and make an impact in space exploration. We include students, undergraduates, and young professional volunteers from 16 different government and private universities. We help students to develop their technical and leadership skills by providing opportunities to manage and participate in national and international projects as well. So likewise, we are currently working on some research projects like underwater monitoring research project and CubeSat development project. So I hope you also will be able to join with us in to contribute these projects for the upcoming projects as well. As I got to know, there are lots of submissions have received for the competition. So I hope this would be really competitive, and with the help of our honorable judge board, we'll be able to raise best out of the best ideas from you. This is to the competitors. Try to take this opportunity to take the maximum out of this opportunity. Our effort is to create a good researcher who is thirsty on knowledge, not a competitor. So take this opportunity to improve yourself, to sharp up your skills. I wish you all the best with the competition. Thank you everyone and good night.
Thank you, Ms. Tashmila. I invite Ms. Akila Banu to explain more about this competition.
Good evening, all of you. I am Akila Banu, chairperson of NuFora Organizing Committee. I would like to briefly describe the competition as an answer to the various questions about NuFora raised by team members. The concept was first developed by the Biomedical and Earth Science Division of SEDS Sri Lanka. I think you all know about what is SEDS and what are the purposes of SEDS. We mention all details in the guidebook, so please refer to it. NuFora21 is a competition that will open to all undergraduates from state or private universities and school students. Your challenge is to research and produce nutritional supplement for astronaut by using algae or seaweed as one ingredient. We collect the project proposals from all teams and individual participants. We will provide all rules and regulation and deadlines. Our judge board will select the best 20 proposals out of them. So work hard and be selected among the top 20 ideas. The participants with the best ideas will be selected for the next round. It is a presentation round. Selected teams are required to give a short presentation about their product, and the best 5 participants will be selected. All rules and regulation will provide step by step. And finally, those 5 contestants have to develop their product practically and submit the research paper. At the final round, we select the 3 places as winner, first runner-up and second runner-up among the participants. And apart from the above 3 places, best school team awarded as the best young scientist of NuFora21. Competitors who are selected for the final round will be awarded certificates. The winning team will be supported to improve their products. We will protect your ideas and provide any help you need to move forward. We have planned workshops and other things to take you forward. Hope you all will stay in touch with us. Finally, as my point of view, I think NuFora21 is the first competition with this concept that I have seen in Sri Lanka. So this can be a turning point in your life. Work hard and get to a chance. Uh, Feel free to ask any question regarding this. Again, thank you for the participation.
Thank you, Ms. Akila Bano. And now this time is for questions about NuFora. You can ask any question you have about NuFora competition. And we invite all of you to turn on your camera to capture this memorable moment. And I should remind, please subscribe to our YouTube channel for this session and previous webinar recordings. Link will be there in the chat, and you can find the link from the chat box. Okay, thank you all. And if you have a question, you can ask any question from us, and we'll always there for you to clarify your doubts and all. And finally, I would like to thank our panel of judges for being with us at this moment, and all the participants. Thank you very much for joining with us, and I would like to thank our organizing committee for organizing this memorable event, and Miss Gagani Atukorala, I would like to thank you, and it's very interesting this session. And I wish all of you good luck in competition. And please don't be hesitant to contact us at any time, so you can ask any question. Thank you.